From ChatGPT and Gemini to AI that can dream up incredible images and even discover new drugs, it really feels like we're living through a kind of AI Big Bang, right? This explosion of new tech seems like it just appeared out of nowhere. But what if I told you that most of it, and I mean a huge chunk of it, can be traced back to a single spark, a single research paper from 2017? In this explainer, we're going to trace the story of that one idea and see how it completely changed our world. So, what's the secret ingredient that unlocked all this power? I mean, it's not just about having more data or building faster computers, though, yeah, those definitely help. The real breakthrough was a completely new idea, a totally different way of thinking about how an AI could learn and understand information. And this is it, a 2017 paper from a team of Google researchers with this brilliant title, a clever nod to the Beatles, "Attention is all you need." This single paper introduced a new architecture called the transformer, and that, right there, is the fundamental building block for pretty much all the generative AI we see today. Now, this wasn't just another small step forward. No way. This was a total paradigm shift. So let's take a look at just how massive the impact of this one paper has been. Okay, get this. As of 2025, this paper has been cited by other researchers over 173,000 times. To put that in perspective, that makes it one of the most influential scientific papers of the entire 21st century. Full stop. It didn't just contribute to a field, it completely redefined the whole direction of AI research. To really truly get why this was such a game changer, we need to take a quick look at the problem it was trying to solve. So, how did language AI even work before the transformer came along? Well, the older models, things like recurrent neural networks or RNNs, they processed language one word at a time, sequentially. Imagine trying to read a really long book one word at a time, but you're not allowed to flip back a few pages. By the time you got to the end of a long paragraph, the model would basically forget what the beginning was about. It just couldn't handle long-term memory or context. So the 2017 paper came along with this incredibly elegant solution to that memory problem. They asked, instead of forcing a model to remember everything in perfect order, what if you could just teach it how to pay attention to the most important parts? And this is the core innovation, the secret sauce, the self-attention mechanism. It basically gives the AI model the superpower to look at an entire sentence all at once and figure out which words are most important for understanding all the other words. It creates these direct links between related concepts, and it doesn't matter how far apart they are in the text. Let me give you a really simple example. The animal didn't cross the street because it was too tired. So what does it refer to? The street or the animal? An older model might actually get confused here. But with attention, the model learns to put a much higher weight, or attention, on the word animal, so it correctly gets the context. This ability to see the whole picture at once and weigh the importance of every word, that was the game changer. But here's where the story gets really wild. This brilliant idea didn't just stay cooped up in language models. It broke out, and it sparked an absolute explosion of innovation across all kinds of fields in science and technology. Suddenly, the transformer architecture became the foundation for, well, almost everything. Of course, it powers the big language models like ChatGPT, but it was also adapted for computer vision, which led to those incredible AI image generators. And then, it started making massive waves in super complex scientific fields like drug discovery and biology. And maybe the most mind-blowing example of the transformer's power outside of language is in protein folding. Google DeepMind's AlphaFold project applied this same architecture to one of the biggest challenges in all of biology, predicting the complex 3D shape of a protein just from its basic amino acid sequence. I mean, this quote from Professor John McGeehan just says it all. A task that could take a PhD student years of painstaking work in a lab can now be done by an AI in a weekend, sometimes in just minutes. The leap in speed was just staggering. So how big was the impact, really? Well, AlphaFold has now predicted the structures of over 200 million proteins. That's basically every cataloged protein known to science. And then this massive, invaluable database was just given away, made freely available to researchers all over the world. So what does that actually mean for science? Well, It's estimated that this single tool has potentially saved hundreds of millions of years of collective research time. It's dramatically speeding up our ability to understand diseases and develop brand new medicines. And the reach of this thing is truly global. Over 3 million researchers in more than 190 countries are using it. Over a third of the scientific papers that cite it are related to disease research. And what's so critical is that it is totally democratized science. Now, over a million users in low and middle income countries have access to a world-class research tool that they never would have had before. But the story that started with that 2017 paper, it's not over, not even close. In fact, those same core principles are now pushing AI towards a completely new level of intelligence. So, for years, AI development has been guided by this thing called neural scaling laws. It's actually a pretty simple idea. If you make the models bigger, you give them more data, and you throw more computing power at them, they just get smarter. It's the bigger is better principle that created the giant AI models we have today. But now we're starting to see a new evolution. Instead of just making the models bigger to train them, we're now giving them more computing power at the exact moment they need to think. This is called test time scaling, and it's shifting AI from just knowing stuff to actively reasoning its way through problems. And this new approach completely changes how an AI attacks a problem. Instead of just spitting out one quick answer, these models can now break a complex problem down into pieces, think through a bunch of different possible solutions, check them all, and then present a final reasoned answer, often showing you how it got there. It's so much closer to how a human expert would solve a really difficult problem. So from language and art to solving the mysteries of biology, and now to developing the ability to actually reason, all of this grew from one single elegant idea about paying attention. It just makes you wonder, right? What seemingly simple idea being published today is going to be the one that defines the next decade of progress for all of us? If you enjoyed this deep dive into the one paper that really kickstarted the modern AI revolution, make sure you hit that subscribe button. We put out new explainers every week, breaking down the complex ideas that are shaping our world. Thanks for watching.